Hi guys! We are doing the torque and rotation module. My name is Maddie. I want to start with giving you a little introduction to a couple of key definitions that you're going to need to understand the things in this module. The first one is torque, which is a twisting force that tends to cause rotation. The next one is the moment of inertia, which is a quantity expressing a body's tendency to resist angular acceleration. And the third one is angular momentum, which is the product of the moment of inertia and angular velocity. The problem we're going to be doing is focusing mostly on moment of inertia and angular momentum.
Alright, so to start off, we have this problem. A ball weighing 40 grams is spinning with a constant velocity parallel to the ground around a pole. The ball is attached to a massless string that is 40 centimeters long. If the ball travels 2 pi radians in half a second, what is the angular momentum of the ball? And then, for the second question, what is the angular momentum of the ball if we increase the length of the string to 60 centimeters without changing velocity? So in order to solve these two problems, first we have to find velocity. And for solving for velocity, we take the angle divided by time. And so for that we have 2 pi, which is, it travels 2 pi radians in half a second, so we divide that by 0.5, and we find that the velocity is 2 pi radians per second.
So to find the angular momentum of the first circle, we multiply I, which is the moment of inertia, times the angular speed, which we already calculated was 4 pi radians per second. And so to find the moment of inertia, we multiply mass times the radius squared. So we know that the mass is 40 grams, which is 0.04 kilograms, and then the radius was 40 centimeters, which is 0.4 meters. And so to plug in all of that, we get 0.0064 for the moment of inertia, and then plugging that back in to the original equation, we get 0.0256 pi kilograms meters squared per second.
Okay, alright, so for the second part, we want to find the angular momentum if we increase the radius to 60 centimeters. So we first use the angular momentum equation, and it's moment of inertia times the angular speed. And since our we already have the angular speed from earlier, it's already 4 pi radians squared. And to find our moment of inertia, it's just the mass times the radius squared, and our mass is 40 grams, and our radius is 60 centimeters. And if we multiply those, we get 0.0144 kilogram meters second squared. And if we plug this in back to our original equation, we get 0.0576 kilograms meters squared per second for our angular momentum.